and time. Actually, next time you see me on a video, I might actually be out of this, change his clothes, and be wearing a different shirt for once. I did all these videos in the same day. Okay, today's lecture. All right, talking today about angle pairs or angle pair relationships. Yesterday in class, we talked about was just angles. I mean, just a single angle here, a single angle there, and maybe an adjacent angle. In this case, we're talking specifically about pairs of angles and how they relate to one another. And we'll actually bump into some biggies today, so yeah, keep that in mind. Two of them, first of all, are the complementary angles and supplementary angles. Again, that means they're pairs of angles. So a complementary pair of angles is going to be two angles whose sum is 90 degrees. Now, what that means is that if I have this, and I have the right angle symbol here, meaning I have a right angle, all right, and I have this, where I've got two adjacent angles now, and I have angle 1 and angle 2. I'd be able to make a statement here, in this case, that angle 1 and angle 2 are are complementary, all right, because their sum is 90 degrees. The difference here between this and now what we did yesterday is right here. Suppose I told you that the measure of angle 2 down here was, let's call it 30 degrees. Well, if I've got some other random angle over here that happens to measure 60 degrees, we'll call this angle x. And angle x is 60 degrees. Well, it turns out then that these two angles will also be complementary angles. They don't have to be adjacent to be complementary. They simply have to add up to 90. So 60 plus 30, all right, will give us 90 degrees here. All right? The same is true on supplementary angles. So if I come over here and I draw some random angle over here, all right, and I tell you the measure of this angle here is 120 degrees. Well, again, is there any supplementary angle that goes with angle, we'll call this angle y? Is there any angle on the board right now that's supplementary with angle y? Well, yeah, it turns out angle x is supplementary with it because, again, this is going to be 60 plus 120 equals 180. All right? Could I also put an angle over here and say this one's 60 and make them, on the same line? Absolutely. They could be adjacent, don't have to be. All right? So that's how, again, complementary, supplementary work. Simply a sum of 90, sum of 180. You'll hear me refer to these often as comps. And I'll refer to these often as subs. All right, as we go through the year. All right, here we go. Moving over here. Here's the first hg. Okay? Vertical angles, or a vertical pair of angles. Again, we're talking about angle pairs again. Vertical angles will happen when you begin with one of these. Okay? All right, so I've got a line. I've got another line that, using our definitions, intersects. We'll say it intersects here at point M. All right? Well, angle 1 and angle 2 in this case are vertical angles. Vertical angles, all right, basically you need two lines that intersect. They'll be the angles across the vertex from each other. Okay? Next chapter we'll get the vertical angle theorem, okay, which will allow us to do what we're going to do today in tonight's homework. You need to make an assumption. All right, you need to assume that the measure of angle 1 is equal to the measure of angle 2. It turns out that it actually is. All right, by the vertical angle theorem, we'll actually prove this later on. All right, that angle 1 is indeed congruent to angle 2. Anybody see any other angles in the picture that might be congruent to each other? Yeah, absolutely. Angle 3 and angle 4, in this case, are also vertical angles, two angles across the vertex from each other. So I've got two acute angles here, two obtuse angles here, all right, that are congruent to each other. All right? All right. Let's go over here to the next guy. All right, the next guy is a linear pair of angles. Well, let's start here. Suppose I put a dot in the middle of this guy. I put a point right here. We'll call this point A. What kind of angle is this right here? Well, we have a straight angle, correct? I'm classifying angles from yesterday. This is a straight angle. Am I focused? Okay. All right. Straight angle measures what? Well, you know a straight angle is going to measure 180 degrees. So if I draw another angle in here, another ray out of here, and I now have in my picture angle 1 and angle 2, all right, what do you suppose you know about angle 1 and angle 2? Well, what's going to happen basically is this. The measure of angle 1 plus the measure of angle 2 is going to be equal to 180 degrees. All right? Angle 1 and angle 2, because they're on the same line, they share an adjacent side, or they share a common side, these are a linear pair of angles. Okay, so again, two angles that are adjacent to one another on the same line are a linear pair. Tonight's homework, we make the assumption that they're going to equal 180. Linear pair postulate, next chapter, will prove this is true. All right? All right, let's go over here now, and I want to talk a little bit about a perpendicular bisector. Now, the perpendicular bisector is not the important part of my discussion. All right? What's important here is I want to talk about the distinction between what it means to sketch something and to construct something. Because you're going to see on tests where I'm going to tell you to sketch something and you need to do what a sketch says to do. I'm going to have tests coming up where you're going to have to construct something and you need to do what constructing is. It's a specific word that has meaning and you don't mix them up. Okay? So let me come over here and let's sketch a perpendicular bisector. All right, a sketch is, all right, a completely labeled picture. This is what you should be doing on your homework almost every night. On some of your problems, you have to do calculations or work things through to see how they work. Give a good sketch so you know what's going on. So here we go. I'm going to start my sketch with this. Specifically, what do I have right now? Okay, I've only told you one thing. What I have right now is segment AB. Oh, look, there's a line going through AB. At this moment, do I have a perpendicular bisector? The answer is, I don't know. Okay, why don't I know? Well, because I haven't met the conditions of a complete sketch. All right? Is it perpendicular? Can't tell. All right, so let's fix that. Okay, now do I absolutely guaranteedly have a perpendicular bisector? No, it's not complete. All I know right now is that line L is perpendicular to segment AB. But I have no idea if it's what? I can't tell if it's a bisector. So how am I going to tell you it's also bisecting? Well, by putting marks in. All right, I'll call this point C so I can talk about it. All right, so now I'm telling you that segment AC, all right, is congruent to segment BC. All right, and these two lines are perpendicular. Now it's a perpendicular bisector. Again, a bisector is going to do what? Make two congruent segments. So here it is. All right? A construction, all right, is different from a sketch. A construction means you are going to use your straight edge. This is not a measuring device now. I'm only using this. All right? And my compass. This is my version of a compass that I have. All right? It's actually the best board compass I've ever had. All right? And what you're going to do is now you're going to construct it using those two tools only. All right, so I am now going to construct AB. If I told you to construct AB, it would look like this. Oh, look, I have now constructed AB. Go ahead and label it. And now what I want to do is I want to construct, to go along with this, all right, a perpendicular line to go through this, through its midpoint. Well, the way I do that is this. Take my compass, and I'm going to lay one of the ends of my compass down, all right, on one of the endpoints of my segment. I'm going to stretch this out a little past the halfway point. Doesn't matter how far, as long as it's past halfway. And I'm going to draw an arc. All right? I'm now going to come over to point B. Notice I haven't changed my compass. That's why you have a good locking compass, because you're going to be handling it a lot. It needs to stay in spot here, in spot. And I'm going to repeat that exact same process, all right, from vertex B, or from endpoint B. Now, you'll notice what I've now created on the board. I have two more points of intersection. What I'm going to do with those 2 points, by the way, these 2 points are equidistant from A and B both. All right? I'm going to play a game of connect the dots through those 2 points of intersection. If I've done a good job, I now have constructed a perpendicular bisector. Whenever you do a sketch for me, label it fully. Whenever you do a construction for me, make sure you always leave all of your construction marks all right, on the paper. Don't erase your construction marks. They tell me what you're doing, all right? All right, I think that's all I've got for you. Like I said, next time you see me, I might even have a different shirt on. So.